Okay, let's start off with some PicoScope very basic measurements. And I want to measure a couple of the signals on the stepper motor. And when I opened up the PicoScope, this is what I saw, okay? One of the things that you can do in the PicoScope is save some settings and recall settings. So I'm going to do that right now to get the settings I need for the stepper motor. And you probably hear the stepper motor running in the background, but we'll get around that. So click on Open. And right here, I've saved some settings. They're called PS settings. And I've called it stepper 2 channels. I'm going to click on that. And things change. I have a couple of different settings. And you'll notice that the motor is stopping and starting. But what I'm going to do is change the horizontal. Give me a little bit more time on the screen. There we go. Okay, but you see that I've got the correct settings for channel A and channel B. My scope probe has to be set in software to ×10 and on the little switch that's on the end of the scope probe. So make sure those two things are set. One of the things a lot of students find difficult to do is to change these settings over here. So notice I want to have my bottom line on ground. So this is my ground for channel A. Over here on the right is the ground for channel B. So make sure if you want to change that, you can bring it up and down. But one thing you don't want to do is have them overlapping like this. It gets hard to interpret the signals. So I'm going to keep it from doing that. So I want to have that bottom line on 0. I have that right now, 0. And this one is not on 0, so I just bring it down until it kind of locks in on that 0 position. Now that I have that, I have the channel A right here set to plus and minus 10 volts. So what that means is that if it was in the center, it would go up 10 volts and down to minus 10 volts. Same for this side, except we have a slightly different setting. This is plus and minus 20. So 20 up here, minus 20 down at the bottom. So notice if that's 40 volts and there are 10 divisions, it's 4 volts per division. Over here, it's 20 volts, 10 divisions, so we get 2 volts per division. So 5 volts is moving it up around 2.5 divisions. All right. If I bring this back down, here we go. I kind of think this is what I want to have when I'm making the measurements. The other tool that's very important is the measurements tool. And I'd like to know the frequency or the cycle time of channel A. So that's now down at the bottom. And I also want to know the cycle time for channel B. So select B, choose cycle time, and I have that here. And you can also put the phase relationship between one channel and another. So let's try doing that. It's back over here in measurements. I lost it. And multi-channel phase. Okay, and it's telling me it's kind of in the way with my screen, but I've got 45 degrees. And you only get it while you've got the 2 channels running. Now, one of the other measurements I want to make is that's one of the stepper coils and the step signal. In this case, we're getting the signal from pin 45. We're using the counter timer. But now I'm going to measure 2 channels together. So I'm just moving the wire. Got to be careful. But now I'm measuring the wire on the same coil. And I'm going to make these both plus and minus 20. And it's 180 degrees out of phase. So that's on the same coil. So every time it's running, it's showing 180 degrees out of phase. And the cycle time is 4 times the 5 milliseconds on the step signal, because there are 4 pulses for every period of the coil. Now I'm going to move my measurement over 1 more pin. And so I'm on a different coil. Oops, not quite. Okay, there I'm in a different coil, and you can see it's 90 degrees out of phase now. And what I'm going to do is just leave that there, bring the other wire back to my step pin, which is there. And I'm going to move the other wire to the direction pin. Okay, so now I have two channels, but one's on direction. Okay, and you can see the direction. For a second I thought it wasn't working, but the direction is low, then it goes high, then it goes low, so it just proves to me that it's working. One more final thing, I'm going to leave channel A on step, and I'm going to put channel B on one of the coil wires, which is back in a coil wire. And I'm going to pause for a second, just make a change to my program so it doesn't change directions. While I'm at it, let's look at the program. So here I'm using the counter timer, and the Arduino has a 16 megahertz clock. We're dividing it by 8, and that actually gives us a 2 megahertz frequency for the counter timer, which means a period of 0.5 microseconds. So if I want to have a 5 millisecond clock period for my stepper motor, so 5 milliseconds times 200, the amount of steps would give me 1 second. And I want it to be 50%, so I'm going to set the high time to half that amount. So it should take 200 steps for the motor to rotate. It's also very important to make sure that you're making pin 8, which is going to the enable, and pin 4, which is going to change the direction. They must be outputs. And I'm going to start off with both of them low, making pin 45 an output. That's going to be my counter timer. And the program I'm running right now just changes or toggles the direction by basically writing to pin 4 the opposite, that's what this exclamation mark indicates, of the read on pin 4. And then I'm writing to pin 8 a logic high that disables the driver, wait 3 seconds, put it back on, and output for another 3 seconds. Okay, and basically I'm just turning the driver on and off, but I'm going to make a change here. I'm actually going to save this, or not save it, I'm going to delete this part right here. Or actually a better way is to comment it out. If you want to comment out a bigger section of code, this is the way that you do it. Okay. And so that bottom bracket is still part of the program. So now I'm going to transfer this program. You'll probably hear the motor now it's running continuously. It's running so that it takes about, let's count here, 1001, 1002, 1003, and it's back to the starting point. So it's doing 3 rotations per second on the bigger gear and 1 rotation per second on the smaller gear with what I'm using with my hardware. So that's being done with the counter timer. Let's go back to my code, okay, and you can see in the scope that I have 2 channels. They both seem to be synchronized. One of the things I want to show you here is if I were to synchronize on channel A, which is the higher frequency, and don't leave it at that bottom level, you want the trigger point to be a little bit higher than that, somewhere's in the middle. Now notice when I trigger on the higher frequency signal, the other signal moves about left and right. And that's because there are 2 possible trigger points for each one of these. So whenever you have 2 signals that are synchronized, then trigger on the one with the lower frequency. So I'm going to go back to B, but you may have to change the trigger level. In this case, it's okay. Now, let's say I wanted to save all the settings that I have here right now. The one thing that I would do is go to Save, and you have to change this from PS Data to PS Settings, and I might want to call it stepper 2 channels, and it automatically defines the name to a number 2. I can change this to whatever I want, and then I save it. And then if I want to recall it, it's just go to open, and this is the second one I did. And now all of my settings will be there, so you don't have to change everything all the time. Even the readings down here will be what you expect. Okay. The other thing is, if you're measuring, let's say you're measuring something that changes just very infrequently and you want to capture it, that's where you would use single trigger, but not for what we're doing here, because every time I want to capture, I have to press that button up there. So not so great. And then you would use none, and I'm going to get it running, if you want to measure, for example, an AC signal. Let's say I want to measure the supply line for my motor on one channel. That's the motor supply line. I'll make some changes in just a second. And this is the supply line for the motor for the servo. I have to change the ground as well. Just making sure I've got the right ones. And I'm going to put the ground for the servo, or not the servo, but the stepper motor right here. Okay, so the only way to do that, if I tried to use auto trigger, it just wouldn't work. Okay, because there's nothing to trigger on. It's a steady DC line. So whenever you're measuring DC, select none. It's also very useful when you're not too sure what sort of triggering you're going to need. It'll give you some idea of what to expect. And so what's important here, have a look at here. I've got my 0 reference. Let's put it right here. And we're at 4 volts per division. So my motor voltage is 0 volts, 4 volts, 8 volts, probably close to 9.5. You can even bring up a measurement. If I go to measurement and I want to see what the top is of channel B, okay, it's going to tell me somewhere here that's about 9.25. I can do the same thing for channel A, plus I can put cursors there. Okay, so that's the voltage for one channel. This is the voltage for the other, and you get a little menu up here telling you the difference. Okay. Now you have to be careful because it might be comparing one channel with another. So that is actually just that one channel. So I'm going to turn that off and just measure the blue one. So I'm getting about 4.7 volts, and then for the red one, I'm getting about 9.1 with a little bit of noise, and that's expected because we're running a servo motor. Hopefully this brief review of the PicoScope will be helpful. You know, the triggering is important, saving the files will be important. I hope this helps. Bye for now.